going to take a look at a couple of these things and see where they get us. The goal of every statistical study is to collect data, process this data, and use this data to answer a question, make a decision, make an inference about something. Therefore, this is the most critical part. You need a reliable process to obtain your data. Now, they have a little guideline for a statistical study, and I took another one from another book, and it breaks it down a little bit more into each part, so that you don't have to copy all of that. But know that the first thing that you're going to identify is, what am I doing? What am I looking for? What's my unknown, my variable? And what's my population? Because from your population, you can develop your sample. And then we'll look at procedures to help you obtain your sample. Once you have your sample, you know your question, your study, you can go obtain your results. Then you're going to process them. Another thing, this one kind of breaks it down a little bit more than I'm handing it to you. You're going to look for some problems. Here's your number 4. There's your variables of interest. That's their number 1. This kind of breaks it down a little bit more. Your detailed plan, your identify your goal, they're kind of just bounced around a little bit. Analyze your sampling method. This is major in this one. It kind of groups it into number 2 here. So this kind of makes it a little bit more detailed, but it's saying the same thing. The one thing on this one that I handed you, number 5, says watch out for confounding variables. Confounding variables are other things that happen. You say you do a science experiment, and you know when you're testing which soil works better, so you have 3 different kinds of soils to test. You have one that is denser than the other, let's say, and maybe one that's sandy, you know, something that you probably did earlier on. And you had the same seeds, you have to put it in the same sunlight, you have to put it in the same container. So say you ran out of your containers, and one you used a glass pot, one you used a clay pot, one you used a plastic pot. So that's going to make a difference. The clay is going to probably keep the moisture in more, so your water is going to be retained more. So will your plant grow differently? Perhaps. So that's called a confounding variable. You want to keep as many things consistent as possible. You want to consider your wording and your setting of your survey. If you're asking people for their opinions, you want to make sure you're not leading them. Don't lead them to the answer. Like as you might want to say, which candidate do you consider the best candidate? Trump or Clinton? Now, if I don't like either one, you kind of forced me into picking which one of those do I consider the best. And I might not like either one. So you have to be careful how you word your survey. They don't go into like graphs, but they say describe your data using statistic techniques. This is the graphing part. Interpret your data. Same thing here. Interpret your data. Draw conclusions. Make decisions based on that. And again, identify possible errors. Some studies take years. If they're following somebody from birth for nurture versus nature, you probably hear about that in biology. There's always a study, do kids grow up better if they're nurtured? If they're nature versus nurture, you know, if they're hugged more, left in their crib, like there's all kinds of studies for those things. It takes years and years to find out. There have to be an adult before you can actually make a decision. So that could be 20 years you're following this study. If in 20 years you say, well, I don't have most of my people, I kind of lost track of them, or yeah, you know, they all lived in one area, I should have looked at different areas. You just wasted time, money, resources, and didn't get what you expected to get. So this is a very, very critical part in planning your statistical study. Data collection. We look at how to collect data. We have 4 major things that we talk about. And again, just very, very briefly. An observational study. Observational has the word observe. You're just observing. You're giving something and just observing. You're not influencing them. You're not giving them a special pill to make them run faster. You're not sitting down working with them. You're just observing. A good example of an observation is you have a set of blocks and you go into a kindergarten class and you give everybody in this class the same set of blocks and you watch and you see who can build them the highest, how many levels can they make before they topple over. Do kids line them up? Do they center them? Do they put them on the edge so they're always falling over? Do they get frustrated? How long before somebody gets, like a 5-year-old child gets frustrated? Maybe you're trying to see this. So you just observe. You do nothing to help them. You can perform an experiment. An experiment is the same as you do in a science experiment. You treat part of, well, in statistics, we kind of have a control group versus a regular group. You treat part of that population or that sample, and you record their responses. At the same time, you set up a control group. Your control group is not changed at all. So you look to see how did your other group, your experimental group, change. Say I'm giving them, I come up with this pill that gives you tons of energy. And I say, take this pill, and you'll never be tired today. You're going to get all your things accomplished. You'll never forget where you put your homework. You're never going to forget your locker combination. It's going to make your brain work 10 times faster. So I have 2 of the same type of kids. I'm going to give them to my seniors and see what happens. I set it up from a population of all my seniors. I make 2 samples. One is my regular group, one is my control group. My experimental group, I give everybody this pill. And I chart over the next few days how many of their things are they getting accomplished. Maybe we give them a certain amount of things to accomplish. Are you getting all of these accomplished? Can you remember the following things? Of my control group, we give them a placebo. It's a fake pill. It's not really this energy pill. It looks like it, and they don't know that it's not, but it does nothing to their metabolism, does nothing to their memory, and we chart their things that they accomplished during the day. And so that's how you can measure what did your experimental group, how did they change. Now sometimes in this group, we have what's called as the placebo effect. Kind of a psychological aspect of it. If you give me this pill and you tell me I'm going to be high energy, I'm going to get all my things done, I'm going to remember everything I have to do, I'm going to end my day with everything accomplished off my checklist, I'm going to say, this is fantastic. So I start my day, I take my pill, I'm doing this, I'm getting this done, I remember this, I remembered my combinations, I remembered all of this. It's kind of a psychological part to it. So that's called the placebo effect. Sometimes the people that are not really getting the pill, the special medicine or whatever it is, think they are, and they perform better. Eventually, that kind of wears off, the placebo effect, and they settle into, this is not really the right pill. But they don't know. We call this a blind experiment. And it's blind because they don't know that they're taking it. Sometimes the person who's administering this, you have 2 groups. They say I'm giving them the pills. Sometimes I don't know which group I'm giving the pills to. Someone else marks the pills and I hand them out to my groups. That's called a double blind. And the reason they do that is because sometimes the administrator has a little bit of an effect on their groups. Like I might say, I know this group is getting the energy pill, so I might be like, take this pill, you're going to do so great today. And the other group, I'm like, okay, take your pill, you'll feel better today. So you don't want any influence other than what you're giving them. A simulation is another way to collect information to run your study. A simulation you would use if something's not safe to give somebody. If it's too dangerous to perform this experiment. Simulators, a lot of aircraft people use it. You see it in like some of the movies. They go on a simulator. Like even your video games, you know, you're running the race cars off the track and you bounce right back on the track. That doesn't happen in real life. So those are kind of like simulators. Say I wanted to test the effects of lead. We hear all kinds of things about lead, how dangerous it is. So there's no more lead in the paint. There's no more lead. Actually, your lead pencils are graphite. They're not lead. There's a lot of things that don't used to have lead do not contain lead anymore. But I never really knew all the problems of lead, so I want to give my participants lead to see what happens to them. Would that be a safe thing to do? No, that would be very harmful. So instead, I'd probably write some kind of a program that simulates the effects on all their organs if I introduce lead into their system or their blood or whatever. So simulation, radiation is another thing, the effect of radiation. I can't give people exposure to radiation, that's deadly. So you simulate it somehow. The last thing to collect your information is a survey. I just want to know what kind of car do you drive. So I send out a survey. Tell me what kind of car you drive. Make, model. Okay. If it's an entire population, we call it a census. If it's a sample, part of my population, we call it a sample. Okay. So these are ways to go out and collect your data. 4 ways that we study. So just for instance, to determine whether this is an observational study or an experiment, researchers studied the effect of vitamin D supplementation among patients with antibody deficiency or frequent respiratory tract infections. To perform this study, we're doing a study, 70 patients received 4,000 units of vitamin D3 daily per year. Another group of 70 patients receive a placebo daily for a year. So what form of data is this data collection? We have observation, experiment, survey, and simulation. Ryan, what would you say? Did you raise your hand? Okay. Experiment. We're actually administering something. This is my control group. This group of another 70 patients that have all the same characteristics as my 70 patients from my study are given a placebo for a whole year. And we look at the difference between them and see what's happening. And vitamin D is not unsafe to give to people. Researchers conduct a study. Here's another study being conducted to find the U.S. public approval rating of the U.S. president. To perform this study, researchers call 1,500 U.S. residents, and they ask them whether they approve or disapprove of the job being done by the president. What would this be? This is a study, but of the data collections, is it an experiment, an observational study, a survey, a simulation? Yeah, but how would I get their information? Survey. I have to ask them, don't I? Observe, I just watch them and I record. But if I'm going to call, I need to call them and ask them. I call you on the phone. Do you approve or do you disapprove of the president? You have to tell me I approve, I disapprove. Okay? Of the job being done. So this is a survey. Is this a census or a sampling? Census is your whole population. Sampling is a sample. It could be either. We don't know if they have 1,500 residents in their town only. Probably not. Probably a sample and from a bigger population. But either way, they're surveying. An observation is something you give out to somebody and you just observe and record their results. And another observation could be like if you want to introduce something to somebody and you want to watch their expressions and something like that, you have to give them something, but you observe them. You have to be there to see them. Okay, take a minute, read this, and let's see what you think. What would you call this? Observational or experiment? In an experiment, look for something to be given to them. Look for a control group. Are we giving them anything that's going to affect them? Observational because it's an observational because what happens is I want to know what kind of elk these are. They're all elk, 636 elk, and we broke it down into 350 adult cows, 125 calves, 100 branched bulls, and 51 spikes. I didn't know there were so many kinds of elk. But could I have sent them a survey to ask them who they were? I couldn't ask the elks the survey, right? So I had to capture them, observe them, check off what they are, put them back. Right? So this is considered an observational study. I didn't do anything to influence the decision. I just took them one by one, observed them, marked off who they are. I can't survey. I can't send them a survey to say, can you tell me who you are? They're elk. Okay? Okay. All right. Your experimental design. There's three main elements to make sure that you have good control or well design over your experiment. One of them is control. Oops. Control also takes into account if you have any confounding variables, and you don't want any confounding variables, something that will affect the thing you're looking at, your variable. It occurs when we can't tell the difference between the effect of what something else happens to yours. So you want to make sure, same as a science experiment, when you're testing something, if you're testing something that you put into water and you wanted to see when the water evaporates, what is left over, what remains in your pot, you have to have the same conditions every time you run that test. Otherwise, temperature can change, maybe change their absorption rate, maybe whatever. You put it in glass versus metal, that could change. So you want to watch that you control this as you go. The placebo effect, be careful of a placebo because you're comparing your control group to this placebo. Technically, the placebo effect does wear off over time. It does. Blinding, this is what we were talking about before. If it's a single blind, the subjects do not know that they're receiving their placebo, and they should not know that they're receiving it. Otherwise, they will act differently. And a double blind, the experimenter giving out the special pills, they don't know either. So they have no bias, no influence in this. Randomization, everything we do is pretty much at random. You have to randomly assign them to different groups. You can't be the one to choose because then you have bias in this. And we're going to talk about how we randomly assign things probably tomorrow. So you're making sure that they're randomly assigned. Sometimes you block them. You divide them into similar characteristics. Men, women, heights, ages, similar characteristics, similar blocks. Sometimes you have matched pairs. Replication. You do this in science. You want to repeat your experiment as many times as possible to make sure that you get the same results. You do that in statistics. You test different samples from the same population. Now, sometimes we do a test on a sample and it's completely out of our norm. Sometimes we get outliers. They're called an outlier. You can get a single outlier. You can get a sample that's an outlier. And you need to determine, as the experimenter, you need to determine, do I keep this sample or do I say this will never really happen again? For instance, your test grades. You get 92, 94, 92, 93, 52. This guy's an outlier. It's outside of my group. It's going to have an effect on my average. Is this my normal? Maybe I say, oops, I never get a 52. It was the worst day ever. I was late to school. Our bus had an accident. I was upset about something. I didn't eat breakfast. I had such a bad headache. I really never got to study because I left my stuff in school. You have to decide, is that a good representation of your score? So we also, as experimenters, have to decide, is it a good representation? Tomorrow we'll continue and we'll do some of these examples. But this is where we're headed for this little part. Gathering our data, and how are we going to gather this data? And again,